All right, let's take a look at this one. Remember, we are only changing the left-hand side. So what do we want to do? Okay, that's a good idea. 1 minus cosecant. So we can change this cotangent into 1 minus cosecant squared.
Oh, that's so not what I meant.
Oh, what did you mean?
You know the a plus square.
Oh, actually, I did this wrong. Sorry.
I meant like 1 minus cosecant x because it's on the bottom, how we did it last time, and I got real confused.
Okay, all right. Let's try doing this. So cotangent squared, remember that 1 plus cotangent squared is cosecant squared. So cotangent squared by itself is just cosecant squared minus 1. Okay, so this is cosecant squared minus 1. Okay, what should we do next?
Do the thing that's it. Or no, that no, don't do the thing.
Huh? Oh, okay, a plus b, a minus b, so we're going to factor. Cosecant u plus 1, cosecant u minus 1 over 1 plus cosecant u. What's next? Simplify. Okay, we're going to cancel. So cancel that. Cosecant u minus 1. Now let's take a look at the right-hand side. How are we going to get there? You can cry. Yes. Magic can also happen. Okay, we're at the point where we don't know what to do. There is only one last thing to do. You could, but you probably had to do some magic. Because I would, you guys want to try that? There's only, what? Times sine. Okay, so kind of like what Daniel was saying, change everything to sine, cosine, and... Huh? Simpler way? All right. Well, eventually you have to do that. Now, there's only one thing left to do. Change the right-hand side, which we're not supposed to touch, but yes. Yes, I did say no, but there's an exception. You're stuck, right? What are you going to do?
Why do you do this?
All right, so this is where I show you, this is what you do when you were like maybe in kindergarten, you have something like this, like a maze. Okay, so let's say this is the entrance. You start here, and then you're supposed to get out here. And then you said, let's see. Stuck.
So you go home backwards?
So smart. Yes. Go backwards. And he said, oh, that's where they connect. All right, now I know to do this way all the way out. Okay, so that's what you're going to do. You're going to start from the exit. Go back until they both meet. And then rewrite everything the right way. Yes. Oh. Okay. All right. I think that's a no for I don't want to do it instead of no, I don't get it.
I don't get it.
Oh, okay. All right. Hold on. I'll help you later. Okay, so we're going to change the right-hand side. Okay, so change the right-hand side until it becomes the left-hand side. Okay, you can do this. Okay, we're going to change the right-hand side. Cosine u over sine u over 1 over cosine u minus sine u over cosine u. That is 1 over sine u minus 1, which is cosecant u minus 1. Okay, we got to the point where they look exactly the same. There is only one last thing to do. Recopy. Because we are still going to go from the entrance to the exit, not where they both meet. So we're going to recopy.
Why is it 1 minus 1?
Okay, again, once we get to the point where they meet in the middle and they look exactly the same, we are just going to copy it over. Oh. Wimbo is ready to leave.
How did you get 1 over sine?
Yeah, -1. Please explain.
1 over sine minus 1.
Yeah.
Cosine times cotangent times tangent, they're the exact opposites, so they're gonna be, it's gonna be 1. Cosine over sine times sine over cosine. It's all gonna cancel.
What?
Somebody next to Andy explain to him. Okay, I'll explain.
We kind of like ran out.
We kind of ran out of time.
Like I didn't write it down fully. 'Cause
Okay, all right. So basically what we did yesterday, we said when you have something you couldn't figure out, what you want to do is just start from the beginning and then get to a point where, you're kind of stuck here. Then start from the end and then until they match. And then what you want to do is just go one way all the way down, all the way to the end. But to do that, you're going to have to recopy. So wherever they connect, copy the previous one from the exit to here, the previous one from the exit to here, and then the exit down to here. That way you have one proof all the way down that is correct. You guys are okay?
Yeah.
Okay, I don't recommend changing the right-hand side unless you are at the last resort. You just cannot figure out what to do. Okay, let's look at this one. Prove this identity. All right, the right-hand side looks very complicated, but let's not change the right-hand side yet. Let's think about this whole thing. What do you see that is similar between left and right? So talk to your partner. What is similar between the left and the right-hand side? What's similar between the left and the right side? Oh, okay. All right. Okay. Andy and Lisa, what do you think? Both have sine, cosine. Okay, now talk to your partner and say, what is different? Think about how many, what kind. Okay, Wimbo and Raymond, what's different? The power of cosine, okay. On the right-hand side, what's the power? What's the power of cosine? No, on the right.
Oh, right.
Uh-huh. 1. And then on the left? 5. Okay, and then on the right-hand side, how many sines are there?
3.
Like 3 different kinds, right? On the left, there is only 1 kind. Okay, so let's think to ourselves. We somehow have to get from the left to the right. And on the right, there's only power of 1 on the cosine. On the left, there's 5. That means we need to keep 1, get rid of the 4. Does that make sense? Okay, so kind of use that as a clue, right? So this is sine squared. I know I need to get rid of these cosine to the 4th. And I'm going to keep that cosine. Somehow, that cosine to the 4th has to turn into a sine, right? Because if you look at the right-hand side, there's nothing else except that cosine. I want to keep everything else as a sine. So this, for sure, has to turn into a sine. Okay, so now you and your, don't spill the secret. Okay, you and your partner work this out. You're going to somehow change this to a sine and then solve the proof.
So you actually have to